Hey guys, in today's video we are going to look at making a temporary magnet. In your notebook you're going to make sure and take down 3 ways to make a temporary magnet, which you will see here. The single touch method is shown in the first picture, magnetic induction in the second, and electromagnetism in the third. You have to take note it is a temporary magnet that we are trying to make, and therefore its magnetism can be removed. So let's continue the video by looking at the single touch method. Now let's look at the single touch method, and you're going to take this down as your heading, and I will start this off by giving a simple description of what it is. The single touch method occurs by stroking a magnetic material like iron, example an iron bar, with a strong, that is permanent magnet to form a temporary magnet. Now let's look at this picture and I'll explain how the single touch method works. If we have a screwdriver with an iron blade and we place the iron blade next to some paper clips, the screwdriver cannot quote unquote pick up these paper clips. It is not a magnet. If, however, we take this screwdriver blade, which is made up of iron, and we convert it into a temporary magnet, it should be able to pick up these paper clips. Now let us look at how the single touch method works using this diagram, where the single touch method works where a permanent magnet and an iron needle is used, and the bar magnet can be used to convert the iron needle into a temporary magnet. So as seen in the picture, if the permanent magnet is stroked from one end to the opposite end in an anti-clockwise direction, it will produce a temporary magnet, where in this temporary magnet our object or iron object should develop some magnetic poles, that is a south pole or north pole. How do we know which end will become the south pole or north pole? Let's look at this diagram, where the permanent bar magnet is stroked in an anti-clockwise direction. And as we can see, if we start at one end with the north pole, the opposite end of the iron object becomes the south pole. Let's take down a short method in steps on how the single touch method works, and you have to take down this diagram with the method. So step 1, the north pole of a permanent bar magnet is placed at one end of an iron object. Step 2, the north pole of the permanent bar magnet repeatedly strokes the iron object in an anti-clockwise direction. Step 3, if the north pole of the bar magnet is placed at one end of the iron object, the opposite end of the iron object will become the south pole. Step 4, the iron object becomes a temporary magnet, full stop. Right? And you can use your diagram to assist, and this is the single touch method. Let's move on to magnetic induction, also called induced magnetism. We're going to go back to our diagram here. You're going to pause the video and take down this diagram. How magnetic induction or induced magnetism works is by using a permanent bar magnet and iron objects. You might have experienced this as well, where if a permanent bar magnet is placed close enough to an iron object, the iron object can behave like a temporary magnet, that is, an induced magnet. Right, so here's the note. You're going to make sure and pause the video, take it down. It says when a non-magnetized magnetic material is brought near to a permanent magnet, the magnetic material itself will become a temporary magnet. This is called induced magnetism. So for example, if we take a permanent bar magnet and paper clips are placed near to the permanent bar magnet, these paper clips become magnetized. So let's take this down in a few simple steps. Right, so step 1, a paper clip is placed near the south pole of a permanent bar magnet. Step 2, the paper clip becomes a temporary magnet by magnetic induction. Full stop. Step 3, the end of the paper clip closest to the south pole becomes a north pole. Full stop. Next step, the paper clip as a temporary magnet can attract another paper clip and also induce magnetism into a second paper clip. Full stop. And this is induced magnetism in very short detail. Right? You can also see the same example here where we have a permanent magnet and instead of paper clips, iron nails are used, or even steel paper clips because steel is also magnetic. With a simple Google search of induced magnetism, you will see quite a few examples showing what induced magnetism is. Now that we've looked at induced magnetism, and you can do your Google search on your own, let's look at electromagnetism. Right? An iron object can be made into a temporary magnet, that is, an electromagnet, when a current is passed through the wire which is winding around this iron object, example, an iron core or iron nail. Right, so you have to take down that note and the diagram here which shows how an electromagnet can be made, where let's say we take our iron core, iron object, iron nail, and we take some copper wire, which is insulated of course, right? And we wrap it around our iron nail, connect it to a battery, and we switch on the battery. As the current flows through the copper wire, the iron nail becomes a temporary magnet. So let's take that down in a few steps. So after you've taken down your diagram, so step 1, you are going to connect the circuit and allow the current to flow through the wire. Step 2, the iron core, example an iron nail, becomes a temporary magnet, that is an electromagnet, as the current flows through the wire winding around the iron core. Step 3. When the circuit is disconnected, the iron nail is no longer a temporary magnet. Full stop. And this is electromagnetism very simply, where by creating a simple electric circuit here and by winding that copper wire around the iron nail, the current flowing through the wire is going to create some sort of temporary magnetic field that makes the iron nail act as a temporary magnet. So we've touched on electromagnetism in terms of making a temporary magnet. When we look at making a permanent magnet, we will also discuss which end of the object, which is our, let's say, iron object or steel object, which end becomes the North Pole or the South Pole. You have to take note, when making a temporary magnet, we are going to use an iron nail or an iron object. And when we are making a permanent magnet, we will use materials such as steel. Right, so stay tuned while we continue, and we're going to look at making permanent magnets. Right, so thank you for viewing. Make sure to subscribe and like the videos, as well as to go to the Instagram page.